Losing your GPS and DGPS signals on a DP2 vessel is, a pretty serious event. It can happen unexpectedly for a bunch of reasons. These might include solar flares, atmospheric interference, or just plain old equipment malfunction. Your vessel relies on these systems for accurate positioning, and without them, the dynamic positioning system loses its main source of information. This can actually lead to a loss of position if it's not managed the right way. However, a DP2 vessel is built with redundancy in mind. That means you've got backup systems ready to take over. The really important thing is to act quickly, calmly, and methodically. Following established procedures is what keeps the vessel, the crew, and all ongoing operations safe. The very first step is to acknowledge the alarms. The DP console will sound an audible and show a visual warning. This alarm is there to signal the loss of the GPS and DGPS position reference systems. Don't ignore or silence it without understanding exactly what's going on. Right away, you need to inform the entire bridge team about the situation. The master, chief officer, and other dynamic positioning operators must all be in the loop. Clear communication is absolutely critical in these first few moments. Everyone on the bridge needs to understand that the vessel's positioning integrity is potentially compromised, and that a structured response is now underway. Once the bridge team is alerted, the DPO must take control. Alert supervisors and key personnel relevant to the ongoing operation. This includes, for example, the offshore installation manager on a nearby platform or the subsea project supervisor. Let them know clearly that the vessel has lost its primary positioning references and explain that you're now assessing the situation and will provide updates soon. This early notification allows other teams to prepare for a possible pause in operations. It makes sure everyone involved is aware of the increased risk and helps prevent confusion, making it easier to coordinate a safe, vessel-wide response to the incident. The initial response really sets the tone for handling the entire event. A calm and procedural approach is essential. The DPO's immediate actions are what prevent the situation from getting worse. By acknowledging alarms, informing the team, and communicating with external supervisors, you build a foundation of control. This lets the team transition smoothly from the initial alert to the next phase. A detailed assessment of the remaining systems. The goal is to stabilize the vessel's position using the available backup references. This measured response is the hallmark of a professional and well-trained bridge team, always making sure safety is the highest priority. With the initial alarms handled, the DPO's focus now has to shift to the remaining position reference systems. A DP2 vessel is required to have at least 2 other independent PRS available. These are usually a laser-based system like a fan beam or SciScan, and a mechanical system such as a taut wire. You need to immediately verify the health and status of these backups. Check the DP console to see if they're active, stable, and providing reliable data to the DP controller. Look for any error messages or warnings connected to these systems. The main goal is to confirm that the DP system has stable and trustworthy alternatives to the lost GPS signals. Let's take a look at the fan beam system first. Make sure the target prism on the nearby structure is clean and properly positioned. Check the fan beam unit on the vessel for any physical obstruction or signs of malfunction. On the DP console, review the signal quality and data stream coming from the fan beam. What you're after is a strong, consistent signal. Next, inspect the taut wire system. Confirm that the depressor weight is deployed correctly and hasn't snagged on any subsea structures. Check the wire tension and angle readings on the console. A stable taut wire gives very reliable data, but, it does have its operational limits. After confirming the operational status of the backup systems, you need to review the DP system's settings. The DP controller uses a mathematical model that weighs the input from each PRS. When GPS and DGPS are lost, the system should automatically deselect them. But you have to manually verify that this has actually happened. So, go to the PRS settings page on your DP console. Confirm that GPS and DGPS are deselected or have a weighting of 0. Make sure the remaining systems like fan beam and taut wire are selected and properly weighted. This tells the DP system to rely only on the functioning backups for positioning calculations. The DP system's confidence level is another really important check. The system is always running a consequence analysis, which predicts what would happen if the vessel suffered another failure, like the loss of a thruster or an active PRS. With GPS gone, your vessel is operating in a degraded mode. You need to review the consequence analysis to understand the new operational limits. If the system is now in a DP degraded or similar state, this must be formally logged in the DP logbook. The log entry should detail the time of the event, the system's lost, and the new operational status of the vessel. Now that the vessel is stable on its backup references, you have to make some pretty critical operational decisions. The loss of GPS puts the vessel in a more vulnerable state with less redundancy. This means you need to really think about the safety of any ongoing work. If your vessel is involved in high-risk activities like diving, heavy lifting, or pipe laying, you must consider pausing the operation. The decision should always be based on the specific operational guidelines in your vessel's DP operations manual. The safety of personnel and the prevention of damage to subsea equipment are your main concerns. For example, if divers are in the water, a stop-all work order is almost always mandatory. The risk of a position loss, no matter how small, is just too great. The divers should be brought back to the bell or to the surface safely. For lifting operations, you should stop the lift, land the load if it's safe, and wait until the positioning system is fully restored. For less critical tasks like survey work, you might be able to continue, but only with caution. This decision must be made in consultation with the master, the project supervisor, and based on a formal risk assessment of the new situation. To help with this decision-making, use all the monitoring tools available. The DP system's own monitoring pages are your first resource. Watch the position plot, the thruster allocation, and the PRS data history closely. Look for any signs of instability. If your vessel has an inertial navigation system, this can be a really good fallback. An INS can provide a reliable position for a limited time after losing external references. It acts as a high-quality dead reckoning system. Also, make use of manual monitoring. Have a crew member take visual cross bearings to the nearby structure, or use radar ranging to supplement the automated systems. Based on this continuous monitoring, you must define clear stop conditions. For instance, if a second PRS, like the fan beam, starts showing erratic data, you need to immediately stop all operations. Another trigger would be if the environmental conditions, wind, waves, or current, get significantly worse. Increased weather effects put more strain on a degraded DP system. The principle is simple. If your confidence in the vessel's ability to hold its position decreases for any reason, you must halt the operation. It is always better to pause and be safe than to take a risk that could lead to a major incident. Proper documentation and communication are super important after you've stabilized the vessel. The DPO needs to make a detailed entry in the DP logbook. This entry should include the exact time of GPS loss, the alarms received, and the actions you took. Note which reference systems were lost and which ones were kept. Record the new DP system status, any adjustments made to PRS waiting, and the decision to pause or continue operations. This log gives you a legal and technical record of the event, and it's essential for any future incident investigation or audit. You should also notify the vessel's shore-based management and technical superintendent about what's happened. While running on backup systems, a member of the bridge team should start troubleshooting the GPS problem. The first step is to check the physical equipment. Inspect the GPS antennas for any damage or obstruction. Check the cabling and connections between the antennas and the receivers in the equipment room. Honestly, simple things like a loose cable are often the culprit. Next, check the GPS receiver units themselves. Look for any error lights or fault messages on the display. Sometimes, just doing a power cycle, turning the unit off and then on again, can clear a software glitch and fix the issue. If the physical checks don't reveal the problem, the issue might be external. Check for any active NOTAMs or other maritime warnings about GPS interference or testing in your area. Sometimes government agencies conduct tests that can disrupt GPS signals. You can also check online resources that track solar flare activity, since major solar events can degrade GPS performance worldwide. If the problem persists and seems to be external, there's not much you can do except wait for the interference to pass. Continue to operate on your backup systems and keep a high level of vigilance. To sum up the whole process, a decision tree is a really helpful guide. If GPS is lost, first acknowledge the alarm and inform the team. Next, check the status of your backup PRS like fan beam and taut wire. Are they healthy? If yes, verify the DP system has deselected GPS and is stable. If not, you have a more serious problem and should immediately consider moving the vessel to a safe location. If the backups are stable, assess the operational risk. For high-risk operations, pause right away. For lower-risk work, you might continue with caution. In all cases, log the event, notify management, and troubleshoot the GPS. Always remember, procedures are there for a reason. Early recognition and a disciplined response are your best tools to ensure safety when you're dealing with a GPS failure.